Hello. So, as I've announced in class, on this coming Friday, so today's the 5th, Wednesday the 6th, Thursday the 7th, Friday the 8th of April, I will not be in class. I'll have an obligation. As a consequence, I am posting this recording in place of the content we would do in lecture. So the goal in this document, the goal that I have today, is just sketching by hand the graphs of tangent, secant, cotangent, and cosecant in the order written down on screen. So let's go ahead and begin. So the ideas will be really not super high tech. I'll basically say I know what the graph of sine and cosine look at. We have done that on Thursday, the day before this video. If we know what the graph of sine and cosine look like, well, we know what tangent is in terms of sine and cosine. So surely I can just use the fact that I know what the graph of sine and cosine are to figure out at least a qualitative graph of tangent. Let's get started. So step one, just like sine and cosine, we wanted to, it was convenient that we knew what the period was. So let's figure out the period of tangent by simplifying this. And many of you will have done that already. Let's do it. Tangent of x plus pi. Let's see, that's the sine of x plus pi divided by the cosine of x plus pi. And remember, the operation of adding pi, what does that do? Well, it says if I have any angle theta, well, pi is an additional half revolution on top of that. So if there's an angle of theta, then here's an angle of pi plus theta. So it's a reflection across the origin. X and y coordinates become negative. So sine of pi plus theta is equal to negative sine of, well, not theta right now, it's x, divided by negative cosine of x. Negatives cancel. Oh, hey, sine over cosine, that's tangent of x. As a consequence, tangent has the property that when you add pi to its input, you get the exact same output back. It's exactly what the period means. Tangent is pi periodic. The period of tangent is pi. So if we can graph this sucker from 0 to pi, then we'll just take whatever graph we get, repeat it, and that'll be the graph of tangent of x over the whole real line. So let's do that. And I'll go back to this idea. Tangent is sine over cosine. So let's sketch the graph of sine of x. Color coding is nice. Not that color. Graph of sine of x. Let's also sketch the graph of cosine of x. And then we'll use those to figure out what the result is. All right, so cosine, it has the property that it starts at 1. It then decreases until it makes it to pi over 2. Cosine of pi over 2 is 0. And then it makes it down to -1. Cosine of pi is -1. There's the graph of cosine. The graph of sine, sine of 0 is 0. Sine of pi over 2 is 1. Goes back down, sine of pi is 0. All right. Ooh, excuse me. Excuse me. So to figure out the graph of tangent, we'll think about sine and cosine. Tangent is sine over cosine. If I want to know where tangent is positive and negative respectively, I'll figure out where sine and cosine are positive and negative. So doing that, start with cosine. From 0 to pi over 2, cosine is positive. Right? See that by looking at the graph. From pi over 2 to pi, cosine is negative. Sine from 0 to pi over 2 is positive. From pi over 2 to pi is still positive. Tangent, remember, is sine over cosine. Let's see. Positive divided by a positive is positive. Positive divided by a negative is negative. So I do know at least this much. From 0 to pi over 2, tangent is positive. From pi over 2 to pi, tangent is negative. That's where eventually I'll graph tangent. The next thing I'll try to get right is I'll try to get the intercepts and asymptotes correct. So first things first, intercepts, x-intercepts. So tangent of x equal to sine over cosine is 0 when the numerator is 0, right? The only way a fraction can be 0 is if the thing on top is 0. So let's write that down. So that happens when sine of x equals 0. And let's go back to the graph and see. Sine of x is the blue one. When is that 0? 0 and pi. And you know that there are more. There's 2 pi, 3 pi, 4 pi, negative 2 pi, and so on. But right now I only care about the interval from 0 to pi. Right, I'm just going to graph from 0 to pi. So that's good enough for now. So I know I see this intercepted, x-intercepted 0, then tangent becomes positive. See this x-intercepted pi, just before that it's negative. So the graph looks like this so far. Vortical asymptotes. A fraction has a vortical asymptote when you divide by 0. So let's figure out when cosine of x is equal to 0. And again, that'll happen by looking at this graph right here. Cosine is the red function. At pi over 2, it's equal to 0. So there's a vortical asymptote at pi over 2. No, this isn't the color coding that I want. So there's what I know about the graph so far. Now I need to get to that vortical asymptote. So we'll just draw in that vortical asymptote. So there's the graph of tangent of x from 0 to pi. Copying that down here, see a vortical asymptote. There's the graph of tangent from 0 to pi. Now this function is pi periodic. So if I want to get the graph of the whole function, I can take this piece and I can do a bit of shtick here that I couldn't do on paper. I can copy it exactly and put that between pi and 2 pi. From 2 pi to 3 pi, the graph looks the exact same. From 3 pi to 4 pi, the graph looks the exact same. And voila, there's the graph of y equals tangent of x. That feel pretty okay? That went okay, I hope. So whenever you graph something by hand, you can double check that this graph is correct. And let's do exactly that. Let's pull up the graphing machine that I've been using most frequently, though doesn't matter which one you use. All right, and there we see the graph. Yeah, it looks like, well, I guess you won't be able to see exactly where I point. It starts at 0. Oh no, I guess you can. It has this vertical asymptote. And what are the x coordinates getting close to? Around 1.5 something. Yeah, that's around pi over 2. And then it comes back to 0 at pi. It carries on, gets another vertical asymptote, comes back to 0 at 2 pi, and so on. Nice. All right, so here's my intent. Let's do the same thing again. I think I might go slightly out of order in order to accommodate what people want to do. So one thing I'll kind of encourage you to do the exact same thing for cotangent. Go through and get the graph of cotangent, and then we'll come back together. I'm going to do this exactly. So if you want to do that, pause this video, go through these steps, and then come back, maybe put it like 1.5 speed or something, figure out what the graph of cotangent is. All right, so let's do the exact same stuff. So let's try to compute the period first. So to do that, let's compute cotangent of x plus pi. It's going to feel very similar to what we just did. cotangent of x plus pi. Cotangent is cosine over sine. Oh, hey, but adding pi to an angle has the property that sine and cosine both become negative what they used to be. So on the top, I see negative cosine of x. Bottom, I see negative the sine of x. Negatives cancel, leaving me with just cosine over sine. Hey, cool, that's cotangent of x. Cotangent of x is pi periodic. You can change the input by pi, you get the exact same output. As a consequence, if we want to sketch the graph of cotangent, it would be good enough to graph it from 0 to pi over 2. So here's 0, there's pi over 2. I'll try to figure out what goes there. Whatever goes here, I'll copy down and put right there. Then I'll take that and I'll repeat it, and I'll repeat it, and I'll repeat it. And that'll give me the graph. So let's start by just figuring out the positivity, negativity. When is cotangent positive or negative? Well, to do that, cotangent is cosine over sine. So let's start with the graph of cosine. Looks something like that. The graph of sine looks something like that. And let's decide whether things are positive or negative. From 0 to pi over 2, cosine is positive, sine is positive, so cotangent is positive. From pi over 2 to pi, cosine is negative, sine is positive, so cotangent is negative. So whatever the graph of cotangent looks like, it will go from positive to negative. Cotangent is 0 when the numerator of cotangent is 0. That is, when cosine of x equals 0. All right, so go back to the graph. When is cosine of x equals 0? At x equal to pi over 2. That point. Cotangent has a vertical asymptote when the denominator is 0. That is when sine of x equals 0. Oh, neat. That happens there and there. So drawing these in, let's use some color. So cotangent has a vertical asymptote here, a vertical asymptote at pi, a root, an intercept at x equal to pi over 2. It goes from positive to negative at pi over 2. So it'll look something like that. Cool. There's the graph of cotangent. And now I'll follow through the same steps. There's cotangent from 0 to pi. I can take this. Okay, I actually have to select it correctly. No, I want this. I want that too. Take that. I will copy it. Paste it. Since this thing is pi periodic, I know from pi to 2 pi, the graph will look the exact same as it does from 0 to pi. And then from 2 pi to 3 pi, the graph will look the exact same again. There we go. That's better. From 3 pi to 4 pi, the graph will look the exact same again. Negative pi to 0. Cool. So there's the graph of cotangent. And again, to check, I'll go back and reference the machine, see if this looks reasonable. All right, so the blue one is the graph of cotangent. Yeah, there's the vertical asymptote that I promised. There's the intercept. You get to a vertical asymptote again, then it repeats. Nice. All right, so let's do a quick sanity check. So we have some identities for trig functions, and one of them tells us that cotangent is tangent of x plus something. So that means that the graph of tangent and cotangent should be related by something. So take a moment, go through your notes. What's the thing that goes here? All right, so you've gone and done that. Cotangent of x is the same thing as tangent of x plus pi over 2. And since I can't really pause to see if people want clarification, let's just check that. Tangent of x plus pi over 2. That'll be cosine x plus pi over 2 divided by sine of x plus pi over 2. You have to excuse those dogs. What does pi over 2 do? So that's the, well, so this isn't going to be quite right. That's all right. Good thing we air check. So adding pi over 2, what operation is that? That's the operation that takes an angle theta and replaces it with this angle. So the cosine is negative the sine of the original angle. The sine is the same as the cosine of the original angle. So this should give me the same as negative the tangent of x. Oh, this is all wrong. Oh, neat. Fix that. Tangent isn't cosine over sine. I was getting confused because I was talking about cotangent. Tangent is sine over cosine. Sine of x plus pi over 2 is the same as the cosine of x. Cosine of x plus pi over 2 is negative the sine of x. That's not negative tangent, that's negative cotangent. Same conclusion though, right? Cotangent is negative tangent of x plus pi over 2. And let's just think about what that means about the graph. So that means if I want to get the graph of cotangent, I can start with the graph of tangent. That's maybe good enough. Its period is pi. You'll shift it left by pi over 2. So doing that, intercept moves there. There's one period, then it will repeat. All right, so far so good. So that's the graph of tangent of x plus pi over 2. Now I need to deal with this negative sign. What will that do? That'll take all the y values and flip them. So that's all I'm trying to do right now. I'm just taking the blue graphs. All right, so now we compare. This purple graph is supposed to be cotangent. Is that the exact same as this magenta graph? Yeah, cool. So it checks out. This graph is correct. Nice. So moving along, let's sketch the graph of secant. So what is secant? Secant is 1 over cosine of x. So I won't have this advantage of tangent where I can just graph it from 0 to pi. The period of secant is going to be 2 pi. All right, the only way secant can start repeating is if cosecant starts repeating. There's not this nice little fight between sine and cosine, which makes it repeat a little bit more frequently. So I'll sketch secant from 0 to 2 pi. I'll do that by first sketching. I guess cosine was red earlier, so let's keep cosine as red. Sketch cosine from 0 to 2 pi. Let's decide positivity and negativity. So from 0 to pi over 2, it's positive. Pi over 2 to 3 pi over 2, it's negative. And it turns positive again. So that means secant, let's focus from 0 to pi over 2. So secant between 0 and 3 pi over 2, 0 comma pi over 2. Secant of x is 1 over cosine of x, is 1 over positive. Yeah, that's positive. Similarly, it's negative there, and then positive. So I'll use that to generate the graph. Cosine is positive from 0 to pi over 2, negative from pi over 2 to 3 pi over 2, and then positive again from 0 to 2 pi. All right. So now I'll play the same game as I did for cotangent and tangent. This fraction is 0 when the numerator is 0. When is the numerator 0? It never is. There are no x-intercepts, which means I'll try to track down some additional values. Secant equals 1 over cosine has a vertical asymptote whenever the denominator is 0. The denominator is cosine. So I'll figure out when cosine of x is equal to 0, looking at the graph. That's when x equals pi over 2 and 3 pi over 2, and that was maybe too sneaky. There's the intercept at pi over 2, there's the intercept at 3 pi over 2. So I have a vertical asymptote at these 2 points. All right, so I know that it'll look something like this. Cool. All right, so next question. I don't have any actual input set up right now. So what I'll do is I'll try to do something extreme, like a maximum or minimum value kind of thing. Now remember, cosine has a maximum value of 1. So that's like an extreme value. So 1 over 1 will be an extreme value for 1 over cosine. So let's try to solve that. 1 is secant of x equal to 1 over cosine of x is equal to 1. Well, solving that. All right, I see a fraction, so I should cross multiply to get rid of that fraction. So 1 is equal to 1 times cosine of x. When is cosine of x? Well, I guess you could either look at the graph or just know because you know cosine pretty well. 0 and 2 pi. So I know there will be this point here at 0, 1. And this point here at 2 pi, comma 1. All right, when is cosine of x equal to negative 1? Well, same thing. That'll be when cosine of x equals negative 1 itself. When does that happen? Well, it happens there at x equal to pi. All right, so there's the graph of y equals secant of x. At least from 0 to 2 pi. And I know what has to happen now. It has to repeat. So there it is by copying exactly. There it is from 2 pi to 4 pi. And there it is from negative pi to 2 pi. I feel pretty okay. So let's just, I don't know, see what properties we can read off from the graph. So I guess first things first, is it even or is it odd? Or neither, that's an option. Let's see. I take inputs, I reflect them over the axis. I get the exact same outputs. Yeah, so this is even. Not terribly surprising. In some sense, you already knew that was true. The range. No, domain first. So the domain is all of the inputs that give actual outputs. So bad things happen at the vertical asymptotes. So pi over 2 is not in the domain. 3 pi over 2 is not in the domain. But otherwise everything is, well, there's a pattern here. Pi over 2 is not in the domain. Negative pi over 2 is not in the domain. 3 pi over 2 isn't in the domain. Neither is negative 3 pi over 2. Same thing with 5 pi over 2. 7 pi over 2, and so on. Range. Well, let's see. So range is seen from the graph by thinking about what y values get hit. So here I see some y values that get hit. It looks like the biggest y value before something weird happens is y equals 1. Nice. That seemed pretty okay. Well, I don't know why I'm asking. You can't answer me. Cool. So just as before, let's get a computer generated graph and see what it looks like. All right, so let's turn those ones off so I can just see secant. Yeah, so I see the right property, right? It starts at 0, 1. It goes up. There's a vertical asymptote. That vertical asymptote is at approximately, yeah, 2 pi-ish. Goes back to negative 1 at pi, vertical asymptote. And then it keeps on going. Nice. All right, the last thing in the list is secant, cosecant rather. And as you might imagine, the graph of graphing cosecant will be pretty similar to how we graphed secant. So, I mean, I guess there's an option. You could pause this video, just go and fill this in, and then decide whether you want to watch the rest of it, or join me for watching the rest of it. Cool. So you've made your decision. Maybe your decision was to pause the recording, do it yourself, and then come back. That's reasonable. Let's sketch the graph of secant. So the graph of secant is built out of the graph of sine. So let's start with y equals sine of x. It is positive from 0 to pi, negative from pi to 2 pi. So cosecant has the same, right? Cosecant of x is 1 over the sine of x. Cosecant is 0 when the numerator of that fraction is 0, but the numerator is 1. So there are no x-intercepts. There's a vertical asymptote whenever the denominator is 0. When does that happen? Well, you could look at the graph. All right, so encoding those below, there will be a vertical asymptote at 0, at pi, and at 2 pi. I'll do the same thing and try to figure out what x value corresponds to y equals 1. So when is cosecant equal to 1? Well, solving. So that happens when sine of x equals 1. Going back to the graph up here, when does that happen? Well, it happens at the peak of sine of x, pi over 2. Groovy. When is cosecant equal to -1? Well, that happens when sine of x equals -1, i.e. when x equals 3 pi over 2. And that also plus 2 pi k's, but I'm only graphing from 0 to 2 pi right now, so that's all I'm worried about, at least for now. All right. So carrying on. So the graph will have those vertical asymptotes, have this 20 around you point at 1. Same thing there. Then it'll repeat. All right. Cool. So now you know what the graph of all of the trig functions look like. Sine of x. Oh, yeah, it's at another page. What does sine of x look like? Looks something like that. What does cosine look like? Well, similar. It's a phase shift of sine. Instead, it starts at 1 and then does its thing. I'm trying to be careful to draw it so like the zeros are the same as the peaks and valleys of sine. We figured out the graph of tangent of x. What graph is that from 0 to pi? And then it repeats. Y equals cotangent of x. Well, it looks pretty similar, except the vertical asymptotes are switched with the intercepts. And that's not all either. There are the vertical asymptotes where the intercepts used to be. And it's decreasing instead of increasing. Nice. There's cotangent. What does secant of x look like? Something like that. And finally, cosecant, orange. So just like how secant, nope, sine is a shift of cosine, cosecant looks like a shift secant. Cool. All right, so that's all I wanted to talk about today. take a look at the homework, send me emails over the weekend. Let me know if anything is unclear. All right. Y'all have a good weekend. See you on Monday.